Hi guys, today we are focusing on the three commonly used trigonometric functions, which are sine, cosine, which is also known as cos, and tangent, which is also known as tan. Now we are relating these trigonometric functions with an angle theta, so we're going to have sine theta, cos theta, and tan theta. Before we talk about the right angle triangle, I want us to talk about the four quadrants that we have in the Cartesian plane. We have the first quadrant, the second quadrant, the third, and the fourth quadrant. The y and the x-axis of the Cartesian plane intersect each other at a 90 degrees angle, which makes the size of each quadrant equal to 90 degrees. So the size of this angle from the positive x-axis to the positive y-axis is a 90 degrees angle. The size from the positive x-axis to the negative x-axis is 180 degrees. From the positive x-axis to the negative y-axis, we have 270 degrees, and the size of this whole angle is 360 degrees. These angles lie in the Cartesian plane. All the trigonometric functions are positive in the first quadrant. Besides the first quadrant, where all the trigonometric functions are positive, sine theta is positive in the second quadrant, where cos theta and tan theta are negative. Tan theta is positive in the third quadrant, where sine theta and cos theta are negative. And cos theta is positive in the fourth quadrant, where sine theta and tan theta are negative. Now, in the first quadrant, we have 90 degrees minus theta. What this tells us is that in the first quadrant, we have angles that are less than 90 degrees, but also remember that those angles are not less than 0. In this quadrant, you'd find 30 degrees, you'd find 45 degrees, you'd find 60 degrees, and other angles that range from 0 to 90 degrees. In the second quadrant, we have angles that are greater than 90 degrees, so we have 90 degrees plus theta, and we also have 180 degrees minus theta, so the angles that we have in this quadrant range from 90 degrees to 180 degrees. In the third quadrant, where only tan theta is positive, we have angles that are greater than 180 degrees, so we have 180 degrees plus theta. The angles in this quadrant range from 180 degrees to 270 degrees, so we also have 270 degrees minus theta. In the fourth quadrant, we have angles that are greater than 270 degrees, so we have 270 degrees plus theta. The angles in this quadrant range from 270 degrees to 360 degrees, so we also have 360 degrees minus theta. Now let's talk about 360 degrees plus theta. 360 degrees is a full rotation from the positive x-axis all the way around back to the positive x-axis. Adding theta to 360 degrees means that you are doing one full rotation plus an extra angle. So it is like going all the way around once and then going further by a specific angle. 360 degrees plus theta lies in the first quadrant only if theta is between 0 degrees and 90 degrees. So if theta lies inside that range, then 360 degrees plus theta lies in the first quadrant where all the trigonometric functions are positive. In the case where you are simplifying and you are given an angle that is greater than 360 degrees, what you're going to do is you're going to subtract 360 degrees from that given angle until you have a value that is between 0 degrees and 360 degrees. For example, you are simplifying sine 540 degrees minus theta. This angle is not between 0 degrees and 360 degrees, so what you're going to do is we're going to minus 360 degrees from it, which will give us 180 degrees. What this means is that you are doing one full rotation plus an extra 180 degrees angle. Now 180 degrees minus theta lies in the second quadrant where sine theta is positive. Therefore, sine 180 degrees minus theta will give us a positive sine theta. Basically, what happens here is that the quadrant determines the sign, which is either a negative or a positive, of the trigonometric function. To give you a better understanding, we have another example. So we have tan 360 degrees minus theta. 360 degrees minus theta lies in the fourth quadrant where only cos theta is positive. Tan theta in this quadrant is negative. Therefore, tan 360 degrees minus theta will give us a negative tan theta. It is important to note that the function values of 90 degrees plus or minus theta are the only function values that change the trigonometric function you are working with. When you are dealing with function values of 90 degrees plus or minus theta, sine changes into cos and cos changes into sine. To give you an example, we have cos 90 degrees plus theta. 90 degrees plus theta lies in the second quadrant where only sine theta is positive. Cos theta in this quadrant is negative. When you are dealing with function values of 90 degrees plus or minus theta, cos changes into sine and sine changes into cos. So we're not going to have a negative cos theta, but we're going to have a negative sine theta. Another example would be sine 90 degrees minus theta. 90 degrees minus theta lies in the first quadrant where all the trigonometric functions are positive. Sine theta in this quadrant is positive. When you are dealing with the function values of 90 degrees plus or minus theta, sine changes into cos and cos changes into sine. So we're not going to have a positive sine theta, but we're going to have a positive cos theta. Let's talk about the right-angled triangle. A right-angled triangle is a triangle that has only one angle equal to 90 degrees. So in any right-angled triangle, sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and sine theta is opposite over adjacent. Now, the opposite side can also be represented as y, the adjacent side can also be represented as x, and the hypotenuse side, which is the side that is opposite the 90 degrees angle, can also be represented as r. It is important to note that theta is an angle that is measured in an anticlockwise direction from the positive side of the x-axis. We can make use of the Pythagoras theorem to find the length of an unknown side in the right-angled triangle. Perhaps you are given the length of the hypotenuse side, which is the value of r, and the opposite side, which is the value of y, and you are looking for the adjacent side. To find x, we can use the Pythagoras theorem, which is r squared equals x squared plus y squared. We have the value of r and the value of y, so we can make x squared the subject of the formula by taking y squared to the other side of the equal sign. The value of r is 3 and the value of y is 1. 3 squared is 9 and 1 squared equals 1. 9 minus 1 is 8 and square roots both sides of the equal sign, which equals 2 root 2. Now, since x is on the left side of the Cartesian plane where the x values are negative, we are not going to have a positive 2 root 2, but we're going to have a negative 2 root 2. Now that we have all the values, we can now calculate sin beta, cos beta, and tan beta. Sin beta is opposite over hypotenuse. The opposite side is 1 and the hypotenuse side is 3. Therefore, sin beta is 1 over 3. Cos beta is adjacent over hypotenuse. The adjacent side is minus 2 root 2 and the hypotenuse side is 3. Therefore, cos beta is minus 2 root 2 over 3. Tan beta is opposite over adjacent. The opposite side is 1 and the adjacent side is 2 root 2. When you type that on your calculator, it will give us a negative root 2 over 4, which is our final answer. Thank you guys for watching. We'll see you on the next video.